So we're going to have a look at another Sketching Cubics question. I've just called this 11b. It doesn't come from the textbook. So in this case, we're going to sketch the graph of the polynomial x plus 2, 5 subtract x subtract 3. And I've just written here as a bit of information. We'd like to include the roots, the vertical intercept, the direction, and one other point. Okay, and using this one other point can help us determine direction as well. It's another way to do it. So as you'll notice, this is already in factorized form, so I don't need to use the factor theorem. I don't need to do polynomial division. It's all there for me. So I can start straight away by finding my roots. So I'm going to equate the function to 0. So I've got 0 equals x plus 2, 5 minus x, and x minus 3. Oops. Using the null factor law, each one of them must equal 0. So 0 equals x plus 2, which gives x equal to negative 2. 0 equals 5 subtract x, which gives, now with this one it's a little bit tricky. I'm going to take the 5 to this side, leaving me with negative x, and then I'm going to divide both sides by negative 1, so I get x equals 5. If you think about it, it makes sense. 5 take away 5 has to equal 0. So, and the last one is 0 equals x subtract 3. Keep the x there. So I've got 3 roots, negative 2, 5, and 3. I'm going to find my y-intercept or my vertical intercept. I'm going to do that by substituting 0 into my polynomial. So I'm going to have 0 plus 2, 5 minus 0, and 0 minus 3, which gives me 2 times 5, which is 10, times negative 3, which is negative 30. So I've got a fairly low y-intercept. So I'm going to start and have a little think about what it's going to look like. I might add a little bit of more detail in a moment. Here we go. Just pause that for a moment. Oops. Sorry about that. So I'm going to plot my roots. So I've got something at negative 2. I've got something at 3. 3 needs to be a bit further away than negative 2. And I've got something at 5. I've also got that my vertical intercept is at negative 30. So that's quite a long way down. We're going to say this is negative 30 here. Now, because that y-intercept is there, it actually gives us a bit of a clue. Before I had that, I didn't know if my polynomial went this way or whether it went this way. Okay, but now because I've got that, the only way it's going to work is if my line comes down through here and up. So it gives me direction automatically. Now, if I didn't have that, what a good method of finding your direction. Okay, there's 2 things you can do. First thing is look at the x's in your polynomial. Now, this is a positive x, this is a negative x, and this is a positive x. So positive times a negative will be negative. Then that times by a positive is going to stay as a negative. So that means I've got negative x cubed as my leading term if I were to expand it out. So that tells me that it had to go in that negative direction, start high and end low. All right. Another way you could do it is to substitute a point. So perhaps I want to know when x equals 4, do I have a point up here or down here? Okay, so all I do is I substitute 4 into my polynomial. So 4 plus 2, 5 take 4, 4 take 3. So that equals 6 times 1 times 1, which equals 6. So I've just found that when x equals 4, there is a point at y equals 6. So I've got a point here at 4, 6. Okay, so I can do that for anything. I can pick whatever I like. I've just chosen 4 because it lies halfway between 3 and 5. And that confirms the shape of my graph. So now I can try and draw something in that goes through all of those points.